Moving on from interactions between a categorical predictor and a continuous predictor to interactions between two continuous predictors. We have now talked a lot about what it means to have different slopes for two different categories of something, like males and females or trucks and cars. And today we're going to go over continuous interactions. But the types of questions we can ask are actually still almost identical. We're still asking the question of whether x1 relates to y and whether that's dependent on x2. So what does it mean to vary across levels of x2 if x2 is continuous? Like, it made a little bit more sense when I was saying cars or trucks. Because we can ask, is the relation of x1 with y different for cars than it is for trucks? So here's an example. I'm going to dive straight into an example here in a second. What would it mean here if I have a continuous x2 variable and I want to say an interaction with this? The way that I want you to think about it, that I think will help you understand it, is to think about a really low value of x2 and a really high value of x2. So maybe the min and the max, or just low on this and high on this. So I'm diving into this example. This is from a real survey called the Library Typology Survey. And I have a y variable. This is a pre-pandemic y variable, and it's related to how often you go out on a regular basis. And this is how often do you go visit art museums, attend sporting events, go to concerts, plays, or dance performances. And this is actually making me really sad. The mean is 6, and the range was 3 to 8. Oh well. One day we'll get to do those things again. X1 is a variable called inside, and this is a variable I created to represent an index of stuff you can just do in your own house. Forgotten how sad this data set is to analyze right now. So it's how often do you watch TV, do you read the news, listen to music, and read books? And the mean of this was 12 with a score ranging from 2 to 18. My x2 here is find information. So a find information index is the surveyors asked participants, how difficult would it be for you to find information about multiple topics? So that's 1 is very easy to 4 is very difficult. So it's like, how easy would it be for you to find information about what's happening in your neighborhood this week on a scale of 1 to 4? So I summed a bunch of those together, and we get this continuous variable. It's a little bit kurtotic, but it's not too much of a worry. It ranges from 2 to about 20. So I have 3 variables of interest. All of them are continuous. And so my research question for the relations between these variables is controlling for how often people do in-house activities, like watch TV, which is my inside variable. Do those who can find information more easily, which is my find info variable, do they go out to do stuff more often? So here is my representative equation. My y for going out is equal to the intercept plus b1 times stuff you do inside plus b2 times finding information. You'll see that this is an additive relationship. There's no interaction in this model at this point. I'm just asking about main effects and whether these things are related to one another. So here are my additive results. I have done this in a regression model, but it will look very similar within the GLM model. So for inside and find info, we're explaining about 10% of the variance. There's our R squared. This is a significant proportion of the variance. We're doing a good job reducing the error in our model. We can interpret it like, we can interpret the intercept here like this, when inside and find info are 0, our expected go out score is 8. Here is the main effect for inside. Because this is a multiple regression, I'm using these keywords of controlling for. You could also say holding it constant. So holding ease of information constant. Those who did more in-home activities report going out less. Find information you would interpret the same way, but with the opposite coefficients. So controlling for inside, or for two people who are the same on inside. Those who are more easily able to find information report going out more often. Okay, so that's our main effects. But now I want to add an interaction to this model, which is justified right now in class because I want to show you how an interaction works. But to sort of back-end add a question to this, I would ask, does ability to find information moderate the relation between at-home activities or going out? Or I could do it the other way, which is, does the relation between home activities and going out vary across levels of ease of finding information? So you see, I'm using the same words, vary across levels, moderate the relation. But instead of talking about categorical variables, I'm just talking about a continuous one. So here's my equation. You'll see it looks just like what we had before, only now we aren't going to have to worry about those confusing zeros anymore, like we were before. Yay. So here I've just shown you what the multiplication looks like to multiply inside by find info. We get a multiplicative variable. In GLM, it does that for you automatically, so you don't even have to worry about that. So here we have the F-test for the decrease of the error variance in our model. And we're finding that, again, we're still explaining about 10% of the variance, maybe 11. It's gone up a little bit, but not a lot. But the model fits the data well. And then here, because there's an interaction in this model, now we have to, again, be more careful about how we're interpreting things and where we're interpreting them. So we want to say that when find info equals 0, an increase in inside activities is associated with a decrease in going out activities. Or we'd have to say here, when inside equals 0, those who find information online who find information more easily report going out less often. So the difference between what we were saying in this model with an interaction in it and the model without an interaction is this red information. Like now we have to be really specific about where within our x1 variable we're talking about when we're interpreting x2, and where within x2 we're talking about when we're interpreting x1. And the moderation interpretation of this interaction is ability to find information does moderate the relation between at-home activities and going out, 0.008. Does that make sense? Does it generalize pretty easily from one to the other? Pretty well? Okay. Thanks for your thumbs up, folks. So if I want to graph this, what I have done, I really wish I had gotten there they are. Okay, so now I have the actual information. Here I have inside index on one axis. Here I have the go out index, which is my outcome variable on the y-axis. And find information, I've picked 3 points. I picked a low value of 0. I picked a sort of medium-ish value of 5, and then somewhere close to the max with 10. And so you can see that the slope, is different relating inside index with go out index when find information is 10 versus 5 versus 0. See how my slopes are different? But here, maybe once inside index was all the way up at 8, there's not much of a difference anymore, meaning the relation between find info and go out would be pretty close to 0 here by the time we were up at 8. But down at 0, it was much bigger. And I believe if you pull this PowerPoint slide down, the data are on here and the equations are on here. So you can, oh, you didn't see any of my. So you can right click on this and it'll pull up the data set. Not the data set, it'll pull up the equations. Okay, that was an example. And now I want to talk to you a little bit about how do I really know what's going on with my data? Like I can graph it, I can look at it, but if I want to really be able to understand what's happening with this interaction, what do I do? Because remember, when you have an interaction effect, if it looks like this or like this, it doesn't matter. The results of your significance tests are going to vary tremendously depending on where you're looking. Right here, we'll see a small difference or a big difference, no difference or a medium difference, a large difference, and a large difference. So how do I know what we're talking about? The way you can do this is with something that they call probing the interaction. If you find an interaction, you can test at multiple points along one or both of the predictors in order to get a better understanding of where you have regions of statistical significance. Like, where is there a difference between my groups? Where is there an association between x2 and y? Where on x1 is there a relation between x2 and y? Oh, I didn't put this paper on there. Let me make sure I add it. Okay. To probe an interaction, we do something called the pick a point approach, where you would pick a point on one predictor variable and test for the relation on the other variable. Now remember, you basically have just done that. You did some picking a point by plugging in information, which gives you an idea of the size of differences, but it doesn't give you a statistical significance test. In order to get those statistical significance tests, we will recenter your predictors. Do you remember centering? It was from a while ago, like class 2 or 3. Recentering your focal variables, then you recreate the interaction variable, and then you rerun the model. Now, the nice thing is, we've just done this. When we were going over homework 5, you remember I ran it 2 ways? I ran it once when female was 0 and once when male was 0. That's just recentering. All I did was change where 0 is. And by doing that and rerunning the model, I get a totally different result, and it allows me to test the significance of each of those different slopes. And so here,
Professor, quick question about centering.
yeah,
There are several different ways you can go about recentering. Right?
yes,
So you can either center it like at 0, you can center it on the mean, you can center it on some type of other thing.
There are several different places that we can center. We can center at the mean, we can center at 0. You can pick literally any point within your observed range of your variable. And that is recentering. So when we had a dichotomous variable, 0 and 1, recentering was just changing which one of those was 0. Now that we have continuous variables, you can center at the mean, you can center at the minimum, the maximum, or anywhere in between.
If I were to ask, like, how do you determine what would be the best way? Would you say something to the effect it depends on the variable in your question?
Yes, if you want to pick what's the best way, there's no such thing as a best way. There is only what makes sense for the question and what makes sense for the variable. However, a good rule of thumb that you can use is to pick the mean and to pick 1 or 2 standard deviations above and below the mean. So if you have a continuous interaction in your model, like we have here, when I have this in papers that I'm publishing and working on, and I want to talk about the statistical relationships and the differences of the slopes using this pick a point approach, I will almost always pick the mean and then usually 2 standard deviations away from the mean, unless I don't have any data there. And then I pick 1 standard deviation. So it was a little bit better of an answer than you thought it was going to be.
Yes, it is.
You thought it was going to be, good luck, you have to choose. And it's not quite that. So if I am going to center inside at 10, representing now someone who does lots of stuff inside. Before, it was at 0, which is someone who does almost nothing inside. And now I want to do it at 10. What I can do next, come here, is, so I've recentered the focal predictor. You don't have to do that because that's just a regression problem. If you rerun with that new variable in, which is called inside 10, that I just made by subtracting 10 from everybody, these won't be any different because I haven't changed anything about the variance. I've only changed the mean. So now, where I'm interpreting this is when inside 10 is 0 and when find info is 0. Now when inside 10 is 0, inside is equal to 10. I know that's weird. It sounds weird, but that's what it is, right? I changed it so that inside 10 means 0 is 10. So when inside 10 equals 0, those who find information more easily report going out more often. My B here is 0.018. And just to compare, here's the old one. I'm going to flip back and forth. Watch right here. Find information. In inside 10, it's positive. And in find info, it's in inside regular, it was negative. But look, inside 10, this coefficient doesn't change. See that? They're both 0.226. Because, remember how we had our slopes before? So if those are our 2 slopes, we're talking about this line right here. But we're looking at the difference between these 2 points. When it's 0 or when it's 10. Now this line right here still represents the relation between, which was it? Find info, inside. Inside and go out. So this is still the relationship between inside and go out. I'm still talking about this line. My other coefficient is talking about the gap between these 2 lines. So here, the gap is one direction, and here the gap is the other direction. So that's why one of these numbers changes, but the other one doesn't. Okay, so what I want you to do now, I have a little activity. I'm going to set a timer for 6 minutes, and I want you to, well, I just now sort of gave it away, but I'll erase this. I want you to think about what's the same and what's different between these two, these recentered results. And I'm going to pause this recording, be back in a minute. So the question is, but this continuous variable is potentially changeable. Like I could change that in a way that gender is less of a changeable construct. This thing of being inside or finding information, either of those could change within a person. And that's absolutely true. But within any sort of linear model, we're talking about describing the relations we see within these data at the time they were measured, with the idea of what might happen again later. So when we're thinking about what's happening within these data, it takes away that question of, but this could change. Right now, we're just talking about what's happening within these data. So taking that part aside, so now we're going to say that we're only describing what's happening here. The parallel that I drew within this one, I was asking you to draw the parallel to is, before we recentered the variable of gender to make 0 be male or 0 be female. And now what I've done is I've changed inside so that it's inside 0 or inside 10. Can you make that parallel of what happened within those two different analyses? The same kind of thing is happening within those analyses. That also wasn't a question. That was also word vomit. Good thing I recorded it. How about, does anyone have another observation or a way of thinking about why the number for find info has changed? Maybe that will connect it in a different way for Lisa and Colby, who I was working with in a group.
The only thing I could think of, with a caveat that I'm very, very confused about this, but the only thing I could think of is like, say we have our little X in our
I'm going to draw it so that people at home can see. Say we have our little X interaction. Okay.
right? At first I was thinking, I was confused, I thought like, well, if we recenter it, it would either shift up or down. But really perhaps what it's doing rather than shifting up and down, I'm sorry video people, is like we're shifting it like so.
Ooh. So we're not shifting up or down, she said. Not like this.
I'm guessing.
That's true. But we're also not shifting like this. Yeah, like that. We're shifting like that. These are all the different, there's an infinite number of lines we could estimate following this, within this scope of observed or of estimated lines, of estimated relations. We can estimate it by plugging in our different numbers here. We're changing, I guess it's more like this, where our line, like where we're interpreting things. So let me talk to you about why I wanted you to think about this.
Can you explain why the other one and only chose find info?
Can you explain why the other one would only change?
I'm just having a hard time wrapping my head around you focus inside and not find info.
Yes, so we changed what inside is, but inside didn't change. Find info changed. Is that what you're saying?
Probably not.
Okay, we changed what inside means. We recentered inside from 0 to 10. But that coefficient didn't change. Inside is the same as it was before, but it's the one we changed.
I guess my question is, why did that also just find it?
Wait, say that again because you keep breaking up.
Why do we also not consider finding?
Okay, Sarah, can you type it because your mic isn't picking you up, I'm afraid. I'm sorry. I get like half of your sentence and then it cuts out. It's definitely why is something else not doing something, but I don't know what. Why did we not also recenter info when we recentered inside? Okay, so the answer is, this was just an illustration to demonstrate what happens when you recenter things. You can recenter both. We could recenter the other one next and see what happens. But the goal of this illustration is to show you that if you recenter one thing, this is what happens to the model. This is what happens to our prediction. So we already knew about the relationship between find information and go out when inside was 0. We knew that. But if I wanted to know about it when inside is 10, then I have to recenter it. I pick a new point and I run it, and I get the information about the relationship once I have moved to inside is 10. Just like before, remember we've been plugging in points for these interaction models for a couple of weeks to get expected scores for people. So this is just one step before we get all the way to y. We're just looking at how these b's are changing when we're getting into, but before we get all the way to y.
So when you recenter, the slope of one line stays the same, and then the slope of the other one either does this.
Not quite. So when you recenter, does the slope of one line stay the same and the other one change? The answer is no. Because when we recenter, you know what? Let's look at it.
But it's the same in the charts.
It's the same in the charts.
For inside 10 and inside, isn't there one difference?
Yes. Oh, so yes, the slope stays the same, but the lines. Remember, when we're plotting the lines, they don't represent. You don't draw one line for the 0.226 and one line for the 0.066. Remember how we drew one line for males and one line for females? Now we're just drawing one line for find info of 10 and one line for find info of 100. So we're just picking two values and plotting them like we did for homework 5. Let me do that here. Where'd you go? Like we did here. I picked points of 28 and 76 to graph. I just picked these points, 28 and 76, and I picked 0 for males and 1 for females. So those are the points that I picked here in order to get the graph. And if I change this to be something else, to be 28 and 52, it changes my predicted y's.
Are you showing something different?
Yes, I am.
We're still seeing doubles.
I know. Sorry, I'm showing the people on Zoom this thing. Okay, hang on. Let's try again. Okay. Now everyone can see this little thing from our homework? Okay, so if I picked 0 for males and 1 for females to plot. I've got one line for females and one line for males. That's one variable. Each one of those represents the relation between reading and science. So now I have 28 and I have 76, but I could have picked 50. So now if I pick 50, I've got, you see that those slopes moved. Unfortunately, it's keeping this. Let me make this fixed. Okay. So now this is fixed, so it won't change. So those are my slopes when I take this axis and I go all the way out to 78. But if I were to stop it at 50, those slopes changed. because I picked a new point at which to stop. So what I'm saying with these, it's all hiding in there. What I'm saying with these is that when you pick a spot on one variable, you're looking at the relation of x with your other variable and seeing how that changes depending on where you move things. So if this went all the way up to 120, woo, that's terrible. If this went all the way to, say, 100, it goes all the way outside of the scope of what I've set it to. And so I showed you that to talk about how, as I move from one spot on inside 10 to another spot, the slope of the relation between the other one changes.
That helps so much, thank you.
Did it really? Yes. Okay. Now, we can absolutely recenter anything you want to. So when you're doing an analysis and you've put in an interaction and you want to think about, what does this interaction mean for my data? Using this pick-a-point approach can help you explain what's happening in your data, essentially. Okay. That is I think that's all I have for you on this. Oh no, we have a Carmen quiz. You want to break before a quiz or you want to do a quiz first? Nobody cares? Then we'll combine them. Okay, we'll just keep going for now and we'll see how we're feeling after this quiz. Okay, can everyone see the screen where I explain the Carmen quiz? Okay, let's do it. This is a questionnaire about getting the news on the internet. This is a questionnaire from the Pew Research Organization, and they measure the number of topics that people get internet news about. And we're going to predict it by how educated the responder is on a scale of 1 to 7, 1 being less educated and 7 being most educated. And we're going to also predict it from party line, which is, how much are you a Democrat or a Republican? So if you're a Republican, then that's a low score on party line, and if you're a Democrat, it's a high score on party line. And I keep both of those for you when you get to the interpretation slide. And once I've put in the interaction of ed level and party line in this model, what I'm asking is, does the strength of the relation between political leaning or party line and internet news depend on your education level? Believe it or not, I wrote this example prior to the 2016 election. It's from older data, but still works. Now, or you could also ask, does education level moderate the relation between political leaning and getting your news from the internet? All right, so 3 key variables: education, party line, and getting your getting your news from the internet. So the quiz is on Carmen. I think it's part of our module, and if it's not, it's got the date of this class in it, which is 10/11. So up here is your information about those variables I told you about. These are the 4 basic questions, but the rest of it is, the actual questions are in your Carmen page. So go forth and try to do this quiz. I will give you 10 minutes to work on it. There are 6 questions. So I'm still grading the quizzes, and we'll have the quizzes graded for by the end of the day today. So you'll be able to check in and see what your grade looks like on the quiz and take it again if you want to. Whoops, don't look at that. Oh, I guess you can now. That was the answer to the quiz. With this guy. So I'm going to come back to this just to rethink about our centering. So here I have males and I have females, but let's imagine this is something continuous for a second. And this is a low and this is high. And a low score is 0. And what if a high score was, say, 5? Did you see the slope move? And if a high score was 10? So if I recentered this imaginary continuous variable, if I'm centered it here, I'm talking about, if I've centered it here, then I'm only talking about that line. The coefficient associating reading with science would be only talking about this line right here. But if I've centered it at 10, now I'm talking only about this line right here. This would be the slope of the relation between reading and science when this imaginary continuous variable is high. I got a couple of nods. What if I get all the way up to like 13? Look, now it's getting negative. 15.
So if you had like, say if it were like a 5-point scale,
Uh-huh.
you would have like a 1, 2, 4, 5, and you would just have like 5 different lines.
You could have 5 different lines. Yep, you absolutely could. Let's make that happen. Let's say it's a 1 to, I don't know, 1, 2, and 3. 0, 2, and 4, sorry, because now they're even apart. So you could have one line for every possible option, but on a continuous variable, there are almost infinite possibilities in between your minimum and your maximum on a true continuous variable. So as this changes, as you're recentering 1, that's why the coefficient for 1 doesn't change, but the other one does. Because in each case, if I'm looking right here, never mind, let's just talk about this one. Here's this, if I'm looking at 10, right, here's the slope when this imaginary continuous variable is 10. So if I've centered it at 10, you would expect the relationship between reading and science to be near 0. Probably not significantly different from 0, because that is a flat line. Here, it's a pretty positive relationship. Much stronger than it was when reading, this imaginary variable was high. Okay, I want you to mull over continuous interactions in your brain. You're going to get the chance to practice them during lab. There is a homework assignment that's not due this week because it's fall break. It'll be due next week. And you'll have the opportunity to practice doing interactions in your own data. So spend tomorrow playing with your data, thinking about interactions in your own data and what that means. If you want, you can go ahead and see the homework assignment. If you want to start working on it, you can, but it is not due until the 22nd, which is a week from Friday. Okay, let this mull over in your brain. Read those interaction articles again that I gave you, I think, 2 weeks ago. McClelland's, the McClelland article, for example, is up in there, up in the readings from 2 weeks ago. McClendon article. And I think there's 2 or 3 interaction-specific articles. The other thing that's up in the module for this week that I want you to be aware of, oh no, who's talking? Ooh, Sarah says, it feels like we're plotting the derivative of a curve, and you are not wrong, and you're going to get even closer to that next time. So, stop it. Oh gosh. I stopped the wrong thing. I just wanted to show you what's going to be in your homework assignment. No. In your Okay, so next week, because I think we're all very tired and we're going to stop learning new things today. Next week, we're going to talk about nonlinear relationships or polynomial relationships among variables. And so here are 3 readings about polynomial relationships that you might want to read before you come, so you're familiar with the concept before I start talking about it. And probably this one would be the best. I have it labeled as excellent resource. This one is the most complex, and then this is an example of someone who's used that within their research. So you can see how that works within their work. So don't worry about this nonlinear, because we will do that next time. I will actually move it out of this module and put it in next week's module. And I will encourage you, because I feel like there's a lot of fuzzy feelings about, not warm and fuzzy feelings, but like confused fuzzy feelings about this content, to use that discussion post that I made, so that you all can talk to each other about what you're reading and what feels impossible. And I can see what you're reading and what feels impossible, so that I can help answer it on the fly. Okay, class dismissed a little bit early today, and we will meet again next week. Please try to take a break this week. Please, please, please.
Thank you, Dr.